Hey, it's Mr. Lum, and we're going to be talking about percent yield and percent purity and looking at what those things are and how to calculate them. So, hopefully, we are now, or you are now, feeling good about calculating doing stoichiometry and calculating how much product you're going to be making in a particular reaction. So, now that is through calculations. So that number is essentially what you should get under what's called a theoretical yield, or under like perfect conditions. That's what you get under calculations. But in real experimental chemistry, you don't always get what you calculated. You might get a certain amount of products. You might be expecting a certain amount, but you actually get less in that regard. And there's a whole bunch of reasons why you can get less products. One, you might not have all your reactants reacting. Sometimes you'll have reactants that are not quite 100% pure. And sometimes, and probably the most common thing, is that your procedures will lose some of the reactants. So mass is lost in procedures, like stuck to a filter paper, stuck to a beaker, or for whatever reason. And so what we can do is we can figure out what is the percent yield of what we actually get. So percent yield is the mass of the product obtained through experiment divided by the mass of the product you expected through calculation. Or in other words, it is what you got or obtained over theoretical. So your theoretical and then times 100%, and that'll equal what is called your percent yield. So your theoretical yield is what you're expecting through calculation. Your obtained or your actual yield, so I've wrote obtained, but you could probably write actual yield, would be considered what you actually got in an experiment. So if I were to like kind of, let's imagine you did some stoichiometry and you had a big calculation, and after your big calculation, it says you should be getting 10.0 grams of something, and that was through doing stoichiometry. So you actually go out, you perform the experiment, you do everything, and you lose some of that, and you don't really know why. You might not have had like the best reactants. You maybe had some stick to your beaker and you lost a few different things here and there, and you only were able to get 8.5 grams of actual product. So your percent yield would be, well, 8.5 divided by 10 times 100. You would have what we call a 85% yield. Okay, so let's take a look at this question right here. It says iron 3 oxide reacts with magnesium. Iron 3 oxide reacts with magnesium to make magnesium oxide and iron. So in this reaction, 24.3 grams of magnesium react with excess iron 3 oxide, and this produces 32.1 grams of magnesium oxide. What is the percent yield? So first off, in this experiment, this person actually did this experiment, and this is what they call their actual yield. But we're not really super interested in that actual yield. We're more interested in that theoretical kind of yield. So what we're going to do is we're going to figure out how much magnesium oxide we'd produce if all 24.3 grams of magnesium react. We have an excess amount of iron 3 oxide, so we don't need to really worry about that. So I'm going to use that 24.3 grams of magnesium, so mg, and I'm going to convert that into moles. And what I'm doing right here is I'm going to convert it into magnesium oxide, so I can compare it to the magnesium oxide I got from my actual experimentation. Now I chose 24.3 magnesium because that is also the molar mass of this. Okay, so the molar mass of magnesium is also 24.3. And then I'm going to go over my molar bridge or use my mole ratio. And I'm going to say that there's 3 magnesium oxide is equal to 3 magnesium, so that magnesium can cancel out. And now I'm going to calculate my molar mass of magnesium oxide, which was 24.3 plus 16, and that is 40.3. Okay. Now, if I go 24.3 divided by 24.3 times 3 divided by 3 times 40.3, my actual number I should get is 40.3 grams of magnesium oxide. So what is this number right here? This is how much magnesium oxide I should get based on calculations. So in other words, that is my theoretical yield. So theoretical yield means theoretically, if everything goes just perfectly, I should get 40.3 grams of magnesium oxide. But in the real world, I didn't get 40.3 grams. I got 32.1 grams. And so I take my 32.1 grams and I divide it by 40.3 grams. Okay, because I take my actual yield divided by my theoretical yield, I times it by 100%, and that equals my percent yield. So my percent yield for this is 32.1 divided by 40.3, and I get 79.65. Or in other words, 79.7% yield. So what is my percent yield? 79.7. Okay. So let's move on to the next question. So for this one, it says you have 10 grams of propane, and the formula for propane is C3H8, and that you try to react, and you produce 10 grams of water. What is the percent yield? So we're going to look at this one right here. So I'm going to take, I make 10 grams of water. So this 10 grams of water is my actual yield. So what I need to do is I need to figure out what is my theoretical yield of water. Okay, so I'm going to find my theoretical yield by taking my 10 grams, and I probably should have chose 10.0 grams for sig fig reasons, but 10.0 grams of propane, which is C3H8, and I'm going to change that into moles, so 1 mole, and the molar mass of C3H8, 12 times 3, and then plus 8 is 44. So 10 divided by 44, and now I'm going to go over my molar ratio, or some people call it the mole bridge. And so I'm going to say that there's 4 water and 1 C3H8. Okay? I'm now going to change it into grams of water by using the molar mass of water, which is 18 grams of water, and that's equal to 1 mole. And now I can find out what my mole ratio is. So I go 10 divided by 44 times 4 times 18 equals, and I was expecting my theoretical yield is 16.36. Okay, so this is my theoretical yield of water. Now, to find the percent yield, I take my actual yield, 10 grams of water, divided by my theoretical yield, 16.36, times by 100, and that gives me a percent. And my percent is, I get a 61.1% yield. Okay. So if you want some more questions and practice on percent yield, try doing these ones on page 137, 35, and 36. But now we're going to work on something called percent purity. Now, percent yield is like how much products you're making. Percent purity is how pure was the reactant that you were using. So a lot of the chemicals that we have in the lab, we have like lab grade, so they are pretty much like 100%. And there are some things in there that are around 99%, things like that. Now, a lot of things that you buy, like grocery store, are less than 100. Like cooking salt is like 99%-ish, and there's a whole bunch of impurities in there. So in order to find percent purity, you can have percent purity is the mass of the pure reactant divided by the mass of the impure reactant and times 100. Okay, so for example, if you found gold ore. Now, ore kind of just means like a rock, and gold, like, well, is an element. But gold ore means like a rock with a little bit of gold inside of it. Okay, so let's imagine you had like a chunk of gold ore, and the gold ore weighed 2.5 kilograms. Okay, now the amount of gold that is in that 2.5 kilogram rock is, say, I don't know, let's say 45 grams. Now, so you had 45 grams of gold inside this gold ore. Okay, so what I do is I would take the mass of just the pure gold, so the mass of the pure reactant that we're interested in, so that'd be 45 grams, divided by the mass of the impure, which is 2.5 kilos, or in other words, 2,500 grams, times by 100, and I can figure out how pure is my gold ore. So 45 divided by 2,500, and I get it's only 1.8% pure. Okay, so how pure is my gold ore? Well, it's only 1.8% pure. Okay, so let's take a look at a more complex question. So here's one right here that says you have 10 kilograms of malachite ore containing 5.25% malachite. And the formula for malachite is Cu2OH2CO3. What is the mass of pure malachite present? So, same thing. I'm going to take pure malachite over the impure times 100%, and that is going to be my percent purity. Okay, I'm going to plug in my numbers. I know what my impure is, 10 kilograms. So I'm going to change that into grams. And the grams of malachite is 10,000 grams. Okay. Now I want to find my pure malachite times by 100, and my percent purity is 5.25%. So in order to find this, I'm going to divide it both by 100 and then times by 10,000. So 525 grams of this malachite that's in my rock. Okay. So when malachite is heated, it produces copper 2 oxide, and it produces copper 2 oxide, CO2, and I didn't subscript the 2 on the CO2, and some water. If the reaction has a 76% yield, how many grams of CuO is produced? And I am trying to remember, what is the molar mass of copper? I want to say it's 63.5. I'm going to actually have to Google it. Molar mass of copper. And so 63.5. So is for copper, Cu. Okay, and the other ones I think I have memorized. So, so when malachite is heated, it produces copper 2 oxide, and if the reaction has a 76% yield, how many grams of CuO is produced? So we're going to ignore that 76% for now, and what I'm going to do is I'm going to find the theoretical yield if all of the 525 grams of malachite reacts. So the formula for malachite is Cu2 bracket OH bracket 2 CO3. I want to change that into moles, so I'm going to go 1 mole is equal to, and the molar mass of copper of malachite is 63.5 times 2 plus 32 plus 3.5 times 2 plus 32 plus 2 plus 12 plus 48. Okay, and I have 221.0 grams is the molar mass of malachite. Okay, so now I've changed it into moles of malachite, and now I want to use my mole ratio to change it into grams of CuO. So there's going to be 2 copper 2 oxides for every 1 malachite. Okay, and if I did this calculation, I would have moles of copper 2 oxide, but I don't want moles of copper 2 oxide. I want grams of copper 2 oxide. So I'm going to go molar mass of copper 2 oxide is 79.5. So I'm going to do this calculation and go 525 divided by 221 times 2 equals, it's times 79.5. Okay, and I get 377.7 grams of copper to oxide. Okay, now this number that I calculated right here is my theoretical yield. That's what I should get, okay? But this experiment only gave me a 76% yield. So how many actual grams of copper 2 oxide did I get? Well, the actual yield divided by my theoretical yield, which is 377.7 grams, times 100, but I'm actually not going to do that, equals 76%, or in other words, 0.76. So if I want to find my actual yield, I need to times both sides by 377.7, and I find my actual yield is 377.7 times 0.76 equals, and the actual amount of copper 2 oxide I got was 287.1 grams of copper 2 oxide. Okay, so my theoretical yield was 377. I didn't get 377 though, I only had a 76% yield. So that means my actual amount through experiments, I got 287.1 grams of copper 2 oxide. Okay, if you want some practice on percent purity, I suggest doing these 3 questions right here and answers in the back, and hopefully that makes sense.